Many YouTube channels and media claims James Webb Telescope to be the replacement for Hubble, but it isn't. James Webb Telescope is mainly the successor of Hubble. There are a lot of important factors where Hubble will still be our best choice. Hubble has given us so many amazing discoveries that scientists became even more eager to see beyond Hubble's range. In particular, more distant objects are more highly redshifted, and their light is pushed from UV and optical into near infrared. That's why observing these distant objects like the first stars, galaxies, black holes formed in the universe requires an infrared telescope. In reality, James Webb or any other space telescope cannot replace Hubble ever. Both telescopes have different sets of capabilities. James Webb mainly observes the universe in infrared, while Hubble has some capabilities of watching infrared, but it mainly scans in optical and ultraviolet wavelengths. Hello fellow humans, I am Devanshu Paul. Keep watching till the end because in this video I shall discuss the difference between Hubble and James Webb Space Telescope. James Webb will watch the universe in infrared using 4 different science instruments. These instruments will provide wavelength coverage from 0.6 to 28 micrometers or microns. Remember, 1 micron is 1 into 10 to the power minus 6 meters. The infrared part of the electromagnetic spectrum goes from about 0.75 microns to a few hundred microns. This means that Webb's instruments will also have some capabilities in the visible range, particularly in the red and up to the yellow part of the visible spectrum. Though the instruments on Hubble can observe a small portion of the infrared spectrum from 0.8 to 2.5 microns, but its primary capabilities are in the ultraviolet and visible part of the spectrum from 0.1 to 0.8 microns. If you have reached this far, consider subscribing and sticking till the end because there is a very special piece of information that you will want to know. So why are infrared observations important? We need infrared observing capabilities because of space dust. The stars and planets that are just forming and even bigger stars stay hidden behind wall of dust. As visible light is absorbed by the dust, that stops us from watching them. But infrared can penetrate this dusty region and reveal what is inside. In this picture, you can see infrared and visible light images from the Hubble Space Telescope of the Monkey Head Nebula. A jet of material from a newly forming star is visible in one of the pillars. Several galaxies are seen in the infrared view, much more distant than the columns of dust and gas. Webb also has a much bigger mirror than Hubble. The larger light collecting area means that Webb can peek further back in time like a time machine than Hubble is capable of doing. Webb will have an approximately 6.5 meter primary mirror, which means Webb has a significantly large light collecting area than any other space telescope. In that place, Hubble's mirror is much smaller, just 2.5 meters in diameter, and its corresponding collecting area is 4.5 meters square, which keeps Webb around 6.25 times more collecting area. If we compare their size, this is a human, this is Hubble's primary mirror, and this is how big Webb's mirror is. But where will the James Webb Space Telescope be placed in space? Unlike Hubble, James Webb will not be placed in an orbit around the Earth, but Webb will orbit the Sun near the second Sun-Earth Lagrange point or L2, which lies approximately 1.5 million kilometers from Earth on the far side of Earth from the Sun. Webb will not be located precisely at L2 but will move in a halo orbit around L2 as it orbits the Sun. In this orbit, Webb can maintain a safe distance from the bright light of the Sun, Earth and Moon, while also maintaining its position relative to Earth. While Hubble orbits Earth just 570 kilometers from the Earth's surface. That means Webb can nearly always see the universe. But how far can Webb see? It can see further than Hubble's instruments can. Let's understand that using an illustration. If this is the whole universe, then this is the place from where the universe started, the Big Bang. This was the Dark Age. The Dark Age is the period between the time when the cosmic microwave background was emitted and the time when the evolution of structures in the universe led to the gravitational collapse of objects, in which the first stars formed. This is how far cosmic microwave background radiation has helped us observe. And this is the point till where Hubble Chandra Deep Field Telescope can see. This is where the first stars were born, and this is the range where the first galaxies were born. And lastly, this is how far James Webb Telescope can see. Now coming to the special part you have been waiting for. Do you know about Herschel Space Observatory? It was also an infrared telescope built by European Space Agency, and the most important part, it also orbited the L2 point where Webb will be. But there is a catch. While James Webb Telescope provides wavelength coverage from 0.6 to 28.5 microns, Herschel went from 60 to 500 microns. Webb is also larger, with an approximately 6.5 meter mirror versus Hubble's 3.5 meters. They both serve different kind of science goals. Herschel looked for the extremes, the most actively star-forming galaxies which emit most of their energy in the far IR, while Webb will find the first galaxies which form in the early universe. For this, it needs extreme sensitivity in the near IR. These were the things you needed to know about James Webb, Hubble and Herschel. But how does James Webb compare with a ground-based telescope like the extremely large telescope?